S is either bigger or smaller than the poles or zero, or depending on the equation. Okay, if ROC is bigger than zero, the transform of UT is 1 over S. If ROC is smaller than zero, the transform is still 1 over S, but the UT is actually minus U negative T. So this is where the bilateral Laplace comes in. Okay? Negative T meaning the left side of the signal. Okay. So you have to remember for the inversion from S to T, if the ROC is smaller, meaning if the ROC is less than zero or on the left side of the signal, then they have to be a negative at the front and negative T. If not, if ROC is bigger than zero or the right sided, so the time domain is just U T. That's the main difference. It's the same for every signal. Okay, for this one, if it's ROC bigger than zero, it's just normal. But if it's smaller, then there's a negative here and then it's a negative T. Okay. Then remember for this function also, for exponent, there's a negative and negative for ROC smaller than the poles or negative alpha in this case. Okay, Laplace transform region of convergence ROC. When you study your mathematics, did you learn on ROC also? Ada tak? Have you learned on region of convergence for Laplace before? No?
Yes, yes.
Oh, you did. Okay. So it's not new lah. Okay. So ROC normally you represent it in a strip line, or we call it like lorry lah. Okay. It can be either like this or like this. It depends. Just like the region has to be shaded or strip lines, or has to be marked within some, using some pattern lah to identify that that is the ROC. Okay, so in this case, normally we use the straight lines parallel to the complex axis, which is the j omega, which is the y-axis of the S-plane. So if xt is absolutely integral and it is of finite duration, the ROC is entire S-plane. If xt is a right, okay, what does a right-sided sequence mean? Meaning that the pole or the equation is right-sided is u t, meaning the time is positive. Positive meaning on the right, so this is ut lah. So if the signal is ut or right-sided, then the ROC real S is bigger than the sigma naught. If the signal is left-sided, so left-sided meaning u negative t, signal is on the left. Okay, so ROC is smaller. Remember, so left-sided smaller, right-sided bigger. So UT is bigger, U negative T is smaller. So similar as in here, if you look, if ROC is smaller, then it's U negative T. If ROC is bigger, then it's just UT. So this is right sided lah. This is left meaning T tu apa? T tu time kan? So this axis is time. So positive UT is the right sided lah. So negative the left sided. Okay? So this is ROC has to be bigger than the poles. We'll look at that later. This one ROC must be smaller. That is the main thing that you have to remember. Okay? So here is an example. Find the Laplace transform n ROC of xt equals to exponent negative 80 ut. So this is ut, which is a right-sided. Okay. You know that the t is on the right side, but it's a positive t. So if you do the transform, exponent negative 80 will become 1 over s plus a. So how do you get this, the ROC? Okay. You have to find the poles. Remember, up here is 0. The numerator is represent the 0 if you make it equals to 0, and then the denominator is poles. So S plus A or alpha equals to 0. So S is minus A. So in this case, the pole is pole, only one pole. Pole is minus A. So since this is a right-sided signal, ROC, RE is bigger than minus A. Minus A ni is the pole. Bigger is because it's a UT. So if you want to plot, okay, this is the S plane. This is your sigma J omega. So let's say the pole is negative, right? So the pole has to be on the left side lah. So negative A, they put negative A here. I'll do it again. So this is your S plane, you have sigma, you have J omega. So your pole is minus A. Minus have to be on the left side lah. So we assume that this is A, which is minus A. So you draw a line around here. So bigger than minus A, it should be bigger, it should be on the right side, okay? So in this case, your ROC ni, ROC real S is bigger than minus A. Okay, so this is how you define your ROC. The important thing is to find the pole. The pole is from the denominator of the equation. Okay. Second example. Now, find ROC and Laplace transform of xt exponent ATU negative t. So this is a negative t, meaning it is a left-sided. Because the t is negative. Yep. Okay. So remember the rule, if it's negative, meaning it has to be smaller. First, find the pole. Pole refer to the denominator. So S minus A equals to 0, S equals to A. So the pole here is A. So ROC, real S, for a, silap ni this is U negative T ni, is smaller than the pole, which is ROC smaller than A. So because, so now you plot the pole first. This is sigma, this is J omega. So pole here is A, it's a positive value. So it could be anywhere on the right side lah. Let's say you put A is here. So you draw a line at A. Now ROC is smaller than A, it has to be on the left side. Okay, so this is your ROC, which is real S smaller than A. Okay, because it's a left-sided. Okay, if you have an equation that has both left and right-sided, how are you going to do it? So let's say we look at the first term first. Okay, xt is exponent negative ATUT plus exponent ATU negative t. So you take the Laplace transform of the first equation, it will become 1 over S plus A. The second one is 1 over S minus A because this is exponent positive A t. Okay, this one is for this one is for this one. Okay, so far okay. If I'm going too fast or if you don't understand, please tell me. Okay, remember the first term is UT, right-sided. So it has to be bigger. So we have to find the pole first. S plus A equals to 0. S is negative A. So the ROC has to be bigger than negative A. For the second term, S minus A equals to 0. S equals to A. And this is a negative or left-sided. So ROC dia, real S has to be smaller than the pole A. So how are you going to plot it? Okay, it's already shown here, but I'll just show you. There's no space. So let's say this is you have sigma and J omega. Or you can write it as a real and imaginary. Okay, it's correct also. So the first pole is negative A. So we assume negative A is around here. and the second pole is positive A. So it should be around here on the right side. So for the first term, the ROC is bigger than negative A. If you look here, this is negative A. We draw a line. So bigger than meaning all the right side of negative A. For the second term, the ROC is smaller than A. So you draw a line at A. Okay, so this is the ROC for the second one. So the combination, so the ROC here is in between or the one that is overlapping. So the ROC here is between minus A and A. So ROC is bigger than minus A, but it is smaller than A. So for a signal that has both left-sided and right-sided, so ROC2 is between a region, like it has to be one is bigger than a pole and the other one is smaller. Okay, if XT is a two-sided sequence, then ROC is the combination of the two regions. Where in this case, the ROC is, for the first term, the ROC is for the positive to bigger and bigger. Then negative A. But for the left-sided too, it is smaller than A. So this is your ROC. Okay? Okay. Ada soalan, any question? Okay. So now let's go over some of the ROC properties. So first thing, no pole can exist in ROC. So at pole's value of Laplace transform is infinity, zero can last anywhere in S-plane, but it won't affect the ROC. So for ROC, we are only looking at the poles, which is from the denominator lah. Okay, let's say if we have XS, S plus 3 over S plus 1 over S plus 1 multiplied with S plus 2. So pole here is S plus 1 equals to 0, which is negative 1. S plus 2 equals to 0, which is negative 2. Okay, if you put back S ni with negative 1 and negative 2 ni, you will get infinity lah. So in this case, there's no pole can exist lah in ROC. Okay. Look at this. This is the right side. Okay, ni ada value yang tadi just now we did it in terms of A. If XT is a right-sided sequence, and if you have two signal. You have one, okay, look at this. We have 3 exponent negative ut and 4 exponent negative 2t. Both are right-sided. So the ROC must be bigger. But bigger than which pole? So the first pole is -1 and the second pole is -2. Okay, which is bigger, -1 or -2?
-1.
-1. So the ROC is bigger than the maximum pole. So ROC in this case is bigger than -1. Okay, if both are right-sided, okay, ROC is bigger than maximum pole. Okay, remember this. Okay, and if you have two signal that are both left-sided, so in this case, so if you, okay, xt is -3 exponent -t u -t minus 4 exponent -2 t u -t. So both are, this is negative. So both are left-sided, -t. So if it's left-sided, you will know that ROC must be smaller, ROC must be smaller. But smaller than which pole? Okay. So the first term, the pole is -1. The second one, the pole is -2. So for this, you have to choose the minimum. Which is smaller, -1 or -2?
-2.
-2 is smaller. Okay, so you choose the smaller or the minimum poles. So the ROC for this case is, ROC is smaller than -2. Oh, I forgot how to draw. Okay, when you plot, we go back to the previous question. You have to plot both pole. So in this case, you have two pole, -1 and -2. But then the ROC is bigger than -1. So you draw a line at the pole -1 and then you shade. Bigger meaning right side lah. Bigger, you should know bigger the right side lah. Smaller is the left side. So for this case, you plot both -1 and -2 pole. So the ROC is smaller than the minimum pole, -2. Okay, so you draw a line at -2 pole, and then this whole area here is the ROC where it is smaller than -2. Okay, so this is your ROC plot lah. Don't forget, even though the ROC is not including -1, but you have to plot both pole or whatever pole that is given in the signal has to be plotted. And then do not forget the axis label, okay? If you just simply draw without axis, marks will be deducted lah because I don't know what is the axis represented. So you have to, if it's an X-plane, you have to have the label of real and imaginary. Okay. Now, if you have, let's say this one. Both are negative signal. So we assume that, so no, if it's negative then ROC must be smaller. So the poles is at -1 and -2. So the smaller pole is -2. Okay, apa ni? Why is like this? So the ROC here is, this case lah, smaller than -2. Okay? If you have both left-sided, this is -t, and right-sided, so you know that for right-sided it has to be bigger, for left-sided it has to be smaller. So for this one, you do the transform is 3 over s plus 1. So why only 3? Where's the negative here? Because, remember this, if it's smaller or you -t, if it's smaller then you have negative here at the front. So 3 over s plus 1 plus 4 over s plus 2. Okay, for the first term, pole is -1. For -1 is negative, right? It's a left-sided. So ROC must be smaller. Okay, for the second term, it's right-sided. And the pole is -2. So ROC dia must be bigger than the pole, -2. So when you draw, so this is -1. Smaller than -1 is the left side. And then this is -2. Bigger than -2 is the right side. So the ROC is the region that they are overlapping here. Okay, this is the ROC, which is here lah. The green area ni. Sorry. So the green area ni, so the ROC ni you can write like this. Bigger, smaller than -1, bigger than -2. Okay, this is your ROC for a two-sided sequence which consists of negative left-sided and right-sided. Okay? Okay, in this case, let's look. Okay, this is a right-sided. And then if you do the transform, you get 3 over s plus 1. And then this is a left-sided. And if you do the transform, you got 4 over s plus 2. For a right-sided, so pole here is -1 kan. Right-sided, it has to be bigger. ROC ni bigger. ROC. Real S must be bigger than -1. For the left-sided, it has to be smaller. So ROC real has to be smaller than -2. If you plot, so this is -1, bigger than -1. Bigger has to be this side, right side. And for this term, smaller than -2. Smaller is on the left side. So there is no overlapping, meaning for this equation, the ROC or the Laplace transform does not exist. Okay? So this is where ROC does not exist and also the Laplace transform does not exist for this case. Okay? Boleh? So you have to remember lah the let's see, wait, let's recap a little bit. So if it's a right-sided, maksudnya UT. So ROC real S has to be bigger than the whole. If it's a left-sided, ROC must be smaller than the poles. But if you have both, you have two right-sided, then you choose maximum pole value. If you have two left-sided, then you choose the minimum pole. So you have to remember ni right-sided ni meaning UT, left-sided is U, negative T. So these are the rules for ROC. Okay. Now, inversion for bilateral is similar to unilateral. It's just that when you are given an ROC, so you have to consider lah when you want to do the inverse transform tu, if the ROC is smaller, then there should be a U negative T and a negative at the front. Okay. If you have 1 over S but the ROC is smaller, then when you do the inverse, it has to have negative T and negative at the front. Okay, in this case, you have to find A, B, and C. Do I have to do it or? Okay, kita buatlah partial fraction ni penat lah. Partial fraction je kan? Just to confirm the value of A, B, and C here. So XS is A over S plus 1 plus minus B over S minus 1 plus C over S plus 2. Okay. Equal to negative 5S minus 7. So you do the multiply, cross multiply this. So A multiply with this is plus 2 minus B is plus 1 is plus 2 plus C is plus 1 is minus 1. So S square, berapa ni? Somebody do it with me please. S square plus 2S minus S is it minus S? Minus 2. Check S square plus 3S plus 2 S square ni apa? S square plus 1 ni. S square minus 1. Betul tak? Yang ni. Betul ke tak ni?
Yes.
Okay, AS square minus AS minus 2A minus B S square minus 3BS minus 2B plus CS square minus C. Yes! Something wrong here?
I think it should be S square plus S, not minus S. First one,
This one S square plus
plus S.
Oh, okay. So this is AS square plus AS minus 2A. Okay. So A minus B plus C S. A minus 3B. Did I miss one more S? No? Okay. minus 2a minus c equals to negative 5s minus 7. So, a minus b plus c equals to 0. A minus 3b equals to minus 5 minus 2a minus c equals to minus 7. Let's try and do with the calculator. So, in this case, you choose 5 and then which one? A, B, C. Is it number 2, okay? So you have A, B, C, so it's number 2. So the first term, A equals to 1, B equals to minus 1, C equals to 1, D equals to 0. Second one is A equals to 1, B equals to minus 3, C equals to 0,
The
and
minus
D.
1, the first one, for B.
First one, what? B,
For
yeah.
B.
Oh yeah, how do I get back to here? Okay, let's do it again. Number 2. A is 1. B is minus 1. C is 1. D is 0. Second one, A is 1. B is minus 3. C is 0. D is minus 5. The third one, A is minus 2. B is 0. C is minus 1. And D is minus 7. So you will get A is 4. Tu ke tak ni? B is 3. And C minus 1. Let's check. 4, 3 minus 1. Huh? Oh, check lah balik eh. Salah ni saya buat ni. There's something wrong somewhere here. Okay, we assume that their A, B and C is correct. Why is incorrect ni? Saya tak dengar lah. I cannot hear.
Tolak 2B, doktor tertinggal.
Which one? Which one?
Yang dekat atas. Tolak 3BS, tolak 2B. Doktor tak letak 2B.
Here is it? So minus 2A plus 2B. Sorry, minus 2A minus 2B minus C, is it? Betul tak? Okay, let's try again. So this is so this should be minus 2A minus 2B minus C equals to minus 7. Okay, we go back to 5. Number 2. So A is 1, B is negative 1, and C is 1, and D is 0. Second one, A is 1, B is minus 3, C is 0, D is minus 5. So the third one, A is minus 2, B is minus 2, C is minus 1, and D is minus 7. Okay. 1, 2, 1. Okay, it's correct. Thank you. It's 1 to 1, is it? So So betul lah, A is 1, B is it negative 2? It's positive kan tadi kan? Okay, tak apa. We go back here first. A is 1, this is 2, this is 1. One to one. Okay. Now, we will ignore first the negative term ni, we'll look back. Okay, now the ROC is bigger than minus 1 and smaller than 1. So this minus 1 and 1 ni is referring to apa? Which one? To this pole here kan? Betul tak? Meaning that s plus 1 equals to 0, s is negative 1. So it's for this term. And then for 1 is this term. S minus 1 equals to 0, s equals to 1. So the ut and u negative t tu, it has to be with for these two pole lah, 1 and negative 1. So when you put back xs, so this is, so ROC bigger than negative 1. Bigger meaning that it must be a u t So for this equation ni, it has to be u t because the ROC is bigger than the negative 1. And for this one, it's smaller than 1. So it has to be u negative t. So that is why the B here, we got positive, right? Positive 2. But since it's negative, because it's ROC tu kan negative kan ni. There's a negative at the front here. So that is why it become negative 2. Okay. And then for this one, we just assume it as a ut because dia tak bagi tahu kan. Okay. So the inverse Laplace is exponent negative t ut for the first one. For the second one is, this is negative, right? So it become positive 2 exponent t u negative t. And then for this one is ut, so exponent negative 2 t u t. Okay? So the ROC here, okay, you have 3 poles, 1, minus 1, and minus 2. 1, minus 1, and minus 2. And the ROC from the question is bigger than minus 1, smaller than 1. ROC bigger than minus 1 but smaller than 1. So bigger than minus 1, this is minus 1, bigger is the right side. But smaller than 1, so it has to be on the left side. So the ROC here is the overlapping. Okay? So this is the xt. So this term here is the left-sided because of ROC is smaller than 1. When ROC is smaller, so it's u negative t. Faham tak? You guys get this? The inversion is the same, but you have to consider the ROC. If it's bigger, then it has to be ut. If the ROC is smaller, then it's negative t. But it depends on which pole lah. In this case, it gives the pole that is involved is negative 1 and 1. So you know it's only these two terms lah. S plus 1 and S minus 1. S plus 2 is not given, so it's always, if it's not given, we always assume it's positive lah, ut. Okay? Okay. We will do a lot of questions regarding that. So don't worry. Now, transfer function. Transfer function of linear, what is LTI? Linear time invariant system is defined as, okay, H, normally it is H equals to Y over S. So Y ni is actually output then X ni is normally is input So HS ni is output over input. Yes, is that a question or what? Okay, can I go back to you later nanti? So HS is output over input. Okay, we are not going to go through the ni, just go to, okay, let's look at this example I don't think we don't need to use this. So you can just use directly. So if it's d square, meaning is s square. Yt become y s plus 3. D over dt is s Yt is y s plus 2 y s equals to 2 s. D over dt ni is s x s minus 3 x s. Okay. So to get the transfer function, which is, as I mentioned, transfer function is y over x. So you have the equation in terms of both y and x. So I'll do again, s square ys plus 3sys plus 2ys equals to 2s xs minus 3xs. Okay, you want transfer function hs, which is y over x. So you factorize the ys at the top. So it is s square plus 3s plus 2 equals to, so you factorize xs, which is 2s minus 3. So hs, which is ys over xs is, so x move to the left, y remain. So this one move to this side and this one move to this side. This one remain 2s minus 3. So it's 2s minus 3 over s square plus 3s plus 2. So this is the transfer function HS. Okay? I think this is quite easy kan ini? Boleh? Okay, so the transfer function HS is 2s minus 3 sama s square plus 3s plus 2. Let's try and do one more example for that before we go to causality ni just ni je. Just okay, so you have to find transfer function, TF transfer function HS, which is y over x. So d square over dt square meaning it's s square. Yt becomes y s plus 2 d over dt is s So s y s plus yt become y s equals to d over dt is s x s minus 2 xt become xs. So you take out ys, so it's s square plus 2s plus 1 equals to, then you take xs out, which is s minus 2. So y over x, which is transfer function hs equals to y over x. So you bring x to the left side, s minus 2 remain on the right side. Then you bring this s square plus 2s to the right side. S minus 2 over s square plus 2s plus 1. Okay? Senang je kan? Any question for this? So this is actually you find the transfer function from the given differential equation. Differential equation ni lah meaning it's in term of d over dt. So if it's square meaning it's s square. If it's just d over dt is s. So yt becomes ys, xt will become xs lah. So 2 tu just 2 lah. Okay. Soalan. Okay, so the last part, causality and stability. So impulse response of a causal system is 0 for t less than 0. Tahu tak impulse response tu apa? Yang delta. Okay, a system pole at S. Okay, ini it's easier to look at the figure. Okay. From the pole location, actually you can determine whether the system is causal or not. So here, a pole in the left half of the S plane corresponds to an exponentially decaying impulse response. Okay, so this is the pole. This is left, right. So the pole here is on the left side of the S plane. So if you inverse it, so you get a decaying exponential response. If the pole is on the right half, this is right and right of the S plane. Okay, right half lah anyway on the right side. So this is normally correspond to an increasing exponential signal lah. Ini exponential lah ni, tapi dia increasing because the pole is on the right side. Okay. For this, if it's on the right side ni, the system is unstable. Remember, a stable system, pole has to be on the left side. We'll look here later. Stability. If the system is stable, the impulse response is absolutely integrable, meaning that you can find the Laplace. So a pole of the system transfer function that locates in the right, this is what I said just now, right side contributes the left-sided decaying exponential. If it's on the left plane, it's a right-sided decaying exponential. It's this figure. It's actually 4.9 and not 4.10. Silap. Okay. This is repeating the same thing. A system that is both stable and causal must have a transfer function with all of its poles in the left half of the S plane. Okay? So if all the poles are on the left, to the left ni, left side, then the system is stable. If you do the inverse Laplace, you get lah stable, system is stable. Okay, for a system to be causal, all poles of its transfer function must be right. Causal, right half, but stable, left. Okay, causal. What does causal mean? Right. Right ni apa? Right. The pole lah. Pole is had to be on. Pole has to be at the right side. But stable, pole has to be on the left side. Left half of the S plane. Okay? That's the difference. Causal right, stable left. Left and right ni we are talking about the poles location of the transfer function. Transfer function tu, transfer function which is y over x lah. Where from the transfer function, let's say this is s plus 1, s plus 2, s plus 3. So you can get the poles from the transfer function from the denominator, which is s plus 2 equals to 0. So the pole 1 is minus 2, and then the second pole is s plus 3 equals to 0. Second pole, s1, s2 is minus 3. So from this, if the pole is on the left side, which is minus, then the system is said to be stable. Okay? If your pole is on the right side, meaning that let's say if s plus 1, s minus 1, sorry, this is minus, minus 1, s minus 2. So your pole is s minus 1 equals to 0. Your pole is 1. No, this is so bad. So s minus 2 equals to 0. Your pole is 2, meaning it's on the right side. 1 and 2, let's say. So the system is causal. Okay. A system is said to be unstable when at least one pole of its transfer function is shifted to the right half. When there is a pole on the right side, it is unstable. Yeah, the system has to be, meaning all the poles for a system to be stable have to be on the left. Left is stable. A system is said to be marginally stable when at least one of pole of its transfer function lies on the complex j omega imaginary axis of x plane, meaning that the poles are on the left and also have one on the imaginary. So this one is marginally stable. Okay. Okay. We will do exercise on Thursday and Wednesday, and after that we will have a quiz. Wait, there's a question ke? Tak ada pun, yang tadi saya dengar bunyi-bunyi tu apa? Do you guys? Any question? Yes? What's the question?
Excuse me, madam, I want to ask about the quiz dates.
Yeah, it's during lecture.
Next lecture?
Yeah, so it will be this Wednesday for electronics and Thursday for computer. So in this Wednesday is not public holiday, okay? For Perlis, 1st of January is working day. So class as usual on Wednesday and Thursday. So the quiz will be on Laplace lah. You have to go through all the notes. Okay, so it's 5% of your overall assessment.
It will cover from introduction till fifth topic.
Yes.
Thank you.
Okay. Any more question? So I hope you have go through the exercise. I have to share back. I'm not sure. Have you download the exercise?
Doctor, the quiz will be what time, Doctor?
So let's say if our class is at 5, then the quiz will be around after we did the exercise lah. Sebenarnya it's only like 20 minutes here, but normally I'll finish early like for the evening class. So we do the exercise around like 40 minutes to 50 minutes and then we do the quiz. Okay? So even though you look at the question, it seems a lot, right? But this is very quick here. It's just how to determine the ROC and then the inverse Laplace with the given ROC. Okay. Any more question? Okay, it will be an objective question, so don't worry. It's A, B, C, D. So you can just choose which is the answer, A, B, or C, or D. So don't worry. Stop recording. If there's no more question, I guess we can stop here. Okay, I will see you guys on Wednesday and Thursday, inshallah. Okay, thank you. Assalamualaikum.
Salam, thank you.
Thank you, Dr.
Thank you, Doctor.
Thank you,
Thank you, Doctor.
Thank you, Doctor.
Thank you.